All right, I just got a notification on my phone, so I think we're probably there.
Yeah.
All right. Welcome to UAB Data Science Club number 40 as Ravi and I continue to travel the world from our desks. I've made it to Hogwarts this week. It seems appropriate for doing any kind of learning. Seems like
And
you're
I'm
in the
yeah, I
wilderness
think
somewhere.
I think I'm somewhere in Amazon. Yeah. I just searched for waterfall and that's where I am.
Well,
I
that's
needed
nice.
I needed some peace.
Yeah. Everybody needs a little peace these days, is what it seems like. All right. So this week, we're going to be looking at setting up machine learning in R. I think last week we did some MATLAB stuff. And then, so this week we're trying to branch out a little bit more and do some R. And so we'll see how that goes. So we've
Yeah,
got a tutorial.
like we mentioned, I mean, for the next few weeks, we'll just be switching on and off from MATLAB and R and talking more about data science in those particular languages rather than Python. We'll come back to Python for sure because a lot of data scientists use Python. And so, but at least for the next couple of weeks, or not couple of weeks, at least for some time, we will be just going back and forth between R and MATLAB.
Yeah. I think that makes sense. So today we're going to look at this tutorial from zero to machine learning with R on towardsdatascience.com. And so we'll post this link in the notes later. But yeah, let's keep on scrolling down and we'll get started with it. Okay, since we're going to be using R, I guess we need to start up a R Studio instance on the cluster. So I'm going to come over here to rc.uab.edu. And why is it going slow?
Yeah, and in the meantime, when Widget starts, so generally whenever you are working on R, you have a couple of options. Either you can just use R and its inbuilt, what's that thing called? Prompts or
the command line.
Yeah, the command line portion of R, and you can run your R over there. And it is plenty powerful. I mean, it does have some level of auto completion. It remembers the history if you save the history in that particular directory in which you are. But if you want to be doing real coding in our language, then the best method would be to use an IDE, and RStudio is the best IDE for our language. We have both options available on Chiha. Either you can just go on command line and load an R module and just start up R via command line, or you can have this interactive app where William is right now and start up an RStudio session.
All right, so I went to rc.uab.edu. I clicked on interactive apps and went to RStudio server. And then I'm going to scroll down and we'll use 3.6.2. That's the latest version of R that we have on the cluster. An hour should be plenty. And we'll use 4 CPUs and 4 gigs of RAM per CPU, or 16 gigs of RAM total. And so we'll go ahead and launch that. All right, so that's going to take a little while to launch. So this tutorial is interesting in that it doesn't have like a start to finish example or project to do, but it does have basically everything that you would want to see when you're getting R set up to do machine learning. I don't know how to clear the console in R. How do I do that?
Maybe CLC.
Let's try that. Oh, no. Profiles. Yeah, apologies. I don't do as much R as, oh, clear workspace. Yes. Okay, I think that just cleared out all of my variables and data. Well, this looks like just the,
Yeah, just the start.
yeah, the start. Before we get started, let's just check our .libpaths function. All right. We'll see how that works.
Yeah.
All right, we might run into some trouble, but we'll figure that out as we go. All right, so R doesn't come with all of the libraries installed. You have to install libraries kind of as you're working. So the first thing that we want to do is install something called TidyVerse, which is a set of libraries that are all really helpful for reading in data, making sure that the data is clean and in an organized manner. And
Yeah.
so we'll take a look at that.
Yeah, and if you're new to R, that's how you actually install new libraries with the command install.packages, and in parentheses you specify the uh, package or library that you want to install.
Object tidyverse not found.
Maybe put it in parentheses.
In quotes.
Yeah, sorry, yes, quotes. My bad.
All right, that looks like that's working. Okay, let's see. All right, I don't know if I already had it installed or if it just installed it, but either way, we have tidyverse now. And
You
you're
might
gonna
have
want to,
dependencies already installed, so tidyverse might have been just a single package that needed to be installed over here.
yeah. So this might take longer when you guys do it in your own space. All right, so now once this is installed, all right, I don't think we want to uninstall tidyverse.
Yeah.
This is just telling us different things that we can do.
Yeah.
Okay. All right. So yeah. So once you have packages installed, just because it's installed doesn't mean that your code will have it available for it. So you do have to specify, even though we just installed tidyverse, we could do like library and then tidyverse. And then that would make everything inside of the tidyverse library available to us. And then similarly, you could load multiple libraries. Here, it looks like basically it's creating an array of library names here. And then this lapply is saying to apply a function to an array. So the array is p.names and the function is library, and that it really is only characters. And so that's what's going on here, is it's just applying the function library to everything in p.names.
Yeah, I mean, this is basically an easy method of not downloading, but incorporating a lot of libraries into your scripts. So rather than just having that library tidyverse, library DeepLiar, library readR, you can actually just specify an array and load all of those libraries for your script in a couple of lines.
Yep. Yeah, absolutely. All right. And then if there's a function that you know of that you want to get more information on, you can either type help or just the question mark and then the function name, or even example and then the function name. And R should have those those things in. When you create your own package, or if somebody else created a package, it's good to document what that package is supposed to do. And so hopefully they've done a good job, and that's what you'll find under help, is the documentation.
Yeah.
All right. Now, so in R, you can define variables on the fly. You don't have to declare the variables before you use them like you would in something like C or C++. And you can assign the variables with either an equal sign or basically what looks like an arrow. So it's like a less than symbol with a hyphen right after it, so that it looks like an arrow where you're saying take what's on the right side and put it into the variable that's on the left side. So let's do that with these couple of things that they have here. So we're going to create the variable myvar and put 54 in it, and we're going to create a vector. And this, so C with parentheses implies that you're making a vector or an array in R. I can't remember what C stands for.
Yeah, me neither.
But if we look in our environment in our studio, then our variables showed up. So that's nice.
Yeah, and these would be available. These variables now would be available in William's workspace till the time this session is ongoing, unless and until he clears out his workspace like he did initially.
Yeah.
And now, wherever he uses these variables, these are the values that would be there, or unless until you change those variables.
Yep. So if I wanted to change my var to not have anything in it, I could assign it to null. And that would empty it out. It doesn't delete the variable, so the variable's still there, but it just doesn't have anything inside of it.
Yeah.
Let's see. So just like in Python and in MATLAB, you can create functions in R. And so let's see what this function's doing. So basically, you write the function the same way that you would in MATLAB. Essentially, you put the word function with what variables you're going to take in as an argument, and then inside of these curly braces, you put the logic that you want inside of there. So this is saying, okay, I want to make a function. I want to take in the creation date, whatever that is, as my variable. So some date as a variable. And if creation date is not a number, so is.na is saying if this is not a number, then return a -1, because -1 would be not a real date, and that would let us know what that wasn't actually a date. But then if it is a number, so else, return the creation date as a date. And so this is, I think, is implying that creation is going to be not in date format when we pull it in, and then this is going to format it as a date and spit it out, and then within our environment we would see that value is set to date.
Yeah, and I mean, so the formatting of the function is very similar to how it would be in any other language as well. If you're familiar with Python or C or most of the other languages, the way of exiting a function is with the return statement. That means basically, if it encounters a return statement, it will exit out of that function. So in that condition, if it finds that the creation date is not a number, then it's going to return some value that's like as dot numeric -1, but it is going to exit out of the function at that point. Else it's going to return with some other value. And over here we are defining it in the name of prod age, this function. So if later on in your code you want to use this function, then you'll have to use the name prod underscore age, and then in parentheses you specify the only parameter that it's taking, creation date.
Yeah, and so I don't know why it's giving us this error that origin must be supplied. Let's Google that real quick. All right, our date, origin must be supplied. Okay, as the X argument. Oh, interesting. This looks like it's a little bit more involved. Oh, okay. So you have, it looks like this is just not quite a complete function. So it looks like it is set up like we assumed to pull in just a numeric value in as the date. Kind of like if you're in Excel and you change a date to just integer, it would show you something like this. Let's redefine our function to include this little bit of logic to put an origin in here.
Yeah. I think we might have an extra parenthesis.
Oh, still an extra parentheses. Okay. Okay, here we go. All right, so now if I do, there we go.
Oh, wow.
Okay.
So that's the number of days.
Yeah. Yeah, so this is saying that, so the origin supplied is just saying what we're considering the beginning of our universe. And then if we put any integer number in here, it's going to make that however many days plus the origin date.
Yeah.
Okay. All right. So yeah, so if you guys see that error, you just got to plug in the origin field. In ours, we plugged in origin equals 1970-01-01 in quotes, and that seems to make it work. Let's see. All right. So working with data frames. All right. So unlike Python, R has this concept of data frames built in. And so even if you don't load any other libraries, R has this capacity to read in a file as a data frame. Let's see. They don't give us a sample data set to work with, but we can at least read in this library and make sure it'll read in. All right, so library read R. I imagine that comes from, where this read_delim function
yeah, I think so.
Comes from. Okay. And so basically what's going on here into this read_delim, which would be short for ReadDelimited. Delimited, yeah.
Delimited, yeah.
Yeah, so it's basically saying, okay, I'm going to read in a text file that is going to have some character between each column, and I'm going to specify what that character is going to be. R also has a read CSV function built into it, but that's going to assume that this delimiter is a comma.
Yeah. That's what CSV stands for, comma separated values generally. You can modify your delimiter, and it is all of those kind of files are nowadays known as CSV, but just as a full form, it's comma separated value. So whenever you see the comma, that's the proper CSV files. But in this case, like William mentioned, that the delimiter is not a comma, it's a straight line or pipeline. So over here, you can specify a different delimiter.
Yeah. And so, oh, can you see that red dot when I put it on there?
I can.
Do I have to click, or does it just
It's
is it
hovering
that?
with here.
Okay, but if I remove it, is it still there?
I mean, it's now with your cursor.
Oh, okay.
So wherever you're moving it, it's
Gotcha.
moving with your cursor.
I gotcha.
All right. Yeah.
All right, cool. So let's see. So let's keep on moving. So all you would have to do is have an actual spreadsheet of some type that you want to read in that's in a text format and delimited by something, tabs, commas, piping characters, something like that. All right, so you can also subset a data frame really pretty easily. So you can take a subset by, if you take your data frame and then the $ and then the name of the column that you want to access, then that will bring in just that single column. So like if you're trying to make your Y or your target predictive values, that's really handy. And then you can also subset it by just indicating which numbers.
So this is for rows.
This for rows? Oh, okay. So for rows, gotcha. So the first one is rows and then the second is columns. So this is saying to just give me my first 100 rows of my 8th column as my training set. And then, okay, so in Python, if you put a negative index, it is indexing from the end of the array. But in R, what this is showing us is that this excludes those indices of the array. So
so it would be 101 to rest of them.
Yeah.
Yeah.
Exactly. But still the 8th column.
Yeah.
All right, so that's pretty handy. Let's see. There's another option, still using bracket. The which and names operator are used to subset. Okay, so this is saying, all right, take my data frame, but take my data frame where the column 1 equals 2. And so that filters the rows. Okay, so which is used for rows is what it looks like. Or can be used for other things probably. But basically saying, give me only the rows where the values of column 1 equal 2. And then give me, in that subset, give me only column 1, column 2, and column 3. This names my data frame in column 1, column 2, column 3. Okay. Let's see. So then there's, in addition to that, and this is the one that I've used before. I didn't realize those other ones. Those are pretty slick shorthand. But if you want kind of a more readable version of what's above, then you can use this subset function, because this basically says, okay, take a subset of my data frame where column 1 equals 2, and where I'm only selecting column 1, 2, and 3. All right, so
that does look more readable.
Yeah, I mean, I think these other ones are slick for making your code really short, but in terms of, like, if you wanted somebody else to be able to come along and read what you've written, I think the subset is the most readable out of these 3 options.
Yeah.
All right. So DeepLiar. Plier is a popular library for data manipulation. DeepLiar introduces a grammar for most common data manipulation challenges. Okay, so if you come from Python, you can do chaining commands. Let's see. So here we can do the same with a special pipe.
Yeah, and I mean, if you guys would have seen us doing some Kaggle videos, we do a lot of chaining where we are like, this is the name of the library, and then we use the dot function, and then we have the function's name, and then we can have another dot function, and either we can find the either we can do the sorting of whatever is the result of the first piping, or we can find out the length or something. So there is kind of like a uh, chaining that we are doing, and that's what it's going to be talking about here. It's just rather than a dot, we have this percentage greater than percentage sign.
Okay. Yeah, so this is saying, okay, so these are different examples. So it's saying from Star Wars, run a filter where I only have species equals droid. Or from Star Wars, select only names that end with color. Let's see.
Yeah, this is basically like our how it works in Python, where you have the name of the either data frame, and then you can use this filter, select, or some other functions that are
Oh, okay,
inbuilt.
okay. Gotcha. So this is like if you were doing like .n unique or something like that
Yeah.
to it. Okay. Or filtering with the pandas function at the end of it. And then you'd have to put that data somewhere
Yeah.
theoretically. Okay. Oh, that's good. All right. Let's see, modifying column values. All right, so when a data frame object is created, we access specific columns with the dollar operator. So we already talked about that before. Let's see. Oh, it looks like this was copied from the above, and when they were creating the article, I was confused as to why it said modify column values twice. All right, so yeah, so you have a data frame and you want to access data, you can access it by saying the name of your data frame, which in this instance is non-conformites, and then dollar or whatever the name of the column is. And you can go ahead and subset that data by doing the same thing again. So you can say, so for my data frame and $ column name, in this case, nonconformities, $regal days or regulation days, we'll say that. Take
Yeah.
only the data in which the number of days is less than 0 and
Change them
put
to
in,
0.
yeah, change that value to 0.
Yeah, because that's why it might be. Well, I'm not really sure about the data set. I don't know if it is possible to have values less than 0. I My assumption would be that at least in this data set, this might not be possible, and it might be an error when entering the data set or creating the data set. That's what we are manipulating and trying to correct.
Quite possibly. Or there's, just like above where it was, we made that function
Hmm.
to create a date. And it's supposed to return -1 when there isn't really a number in that instance. You might enter into a region like that where there's
Hmm.
some time where somebody has used negative numbers to imply that there's not a number, but then you're trying to do some analysis, and so you might be imputing data, or you might know something about those not a number columns that you can then put in there.
Yeah.
Okay. All right. So deleting a column, you can just set it to null. Okay, that's pretty helpful. All right, let's keep on scrolling down. Okay, and applying a function to a column. So that makes sense. So basically, so we've created our function earlier. If we have a column, we can use the apply function to say, okay, so apply to my table inside of just that date created column. So you notice we didn't put anything for the row. So it's just going to assume that we want to look at all of the rows. And then drop equals F, which I'm going to assume means false.
Yeah.
And then, yeah, function of X, where product age, I guess, is that function of X. Okay. All right, so working with dates. So yeah, so it's got an inbuilt date format, which is nice. So you don't have to parse dates.
Yeah.
And then let's see, so exporting data frames, just like it's really easy to read in a CSV or a delimited file, you can export it by just doing write.csv. So that's
and so this is one of the built-in functions. We don't need a library, like William was mentioning earlier, that write.csv and read.csv both are native to R. You don't need a specific library for doing these functions.
Yeah. Let's see. All right. RDS, I'm assuming that's an R data store. I haven't used those before, but if you're listening and you've used one and you think that they're really awesome, please leave us a comment so we can talk to you about it, figure out what the good use cases are for that.
Agreed.
We're generally switching between things a lot of times, so we like to keep things in really portable data formats.
Yeah.
All right, so plotting. So I would say that plotting is one of those places that if you get into it in R, plotting in R is probably one of the best places to plot stuff. It makes it really easy to make really pretty plots. And this is kind of a really dinky example. A few weeks back, before all the quarantining stuff, we did some data exploration in R for one of these videos for the Neuroimaging Journal Club on campus. And so go back and take a look at that one if you want some more examples of plotting in R, because I'd say it's really, really useful. And some things that like Excel won't even do, R will do just out of the box, so without having to add anything else in. So this is a good one for us to copy and paste over so we can take a look at.
Yeah.
So we're just setting an array of values, 1, 4, 8, 2, and 4. And then we're going to do a bar plot, a histogram, a pie chart, and then a box plot of all of those values. All right, so let's see.
So we might just be left with the last one.
Well, actually, thankfully,
it
keeps them all in here. So that's one of the reasons why RStudio is really nice, because it doesn't overwrite your other plots. So this is our bar plot, which you can get one of these in Excel, but it's nice because it kind of just by default gives you a really nice, clean looking graph. And this is infinitely editable. Like you can go in and specify the X label, the Y label, multiple different axes, all sorts of things like that. Let's see. All right. So this is a histogram of the values. and then a pie chart. Okay. And okay, so this pie chart, this 1, 2, 3, 4, and 5 refers to the index. So because we didn't give it what those values were, it just used the index of those values as the label. So 3 is the number 8. So that's
That
why
is
it's
the
printed.
largest. Yeah, that's the largest share of the pie.
And then this is our box plot, which this is a really, really useful thing in science, but something that if you're trying to get Excel to do this is a really big pain. So yeah, as you can see in R, it's really pretty straightforward once you've gotten your data loaded up.
Again, these are inbuilt R functions, so you don't need to specify any library. But if you are getting into plotting uh, graphs for your data set, yeah, like William mentioned, look at the video that we had uh, uh, in February at some point. I would recommend going for the ggplot library because that gives you a lot more a lot of options, and some of them are really, really just weirdly crazy. You can have 3D graphs, you can have live graphs. So you'll have a bunch of options with ggplot library.
Yep. Yep, exactly. All right. So the next portion here, or the final portion, is this is pretty nice. So again, there's no data built into here that we can use. We might be able to use, is it the iris data set? Yeah, there's the iris data set in here. All right. So we're going to call something my.dataframe equals iris. Oh, I guess I need to do the, like this. Okay. So now, so R does have some built-in data sets. So we're going to use this iris data set, which is about flowers, which is a really famous machine learning tutorial data set. And it looks like in order to be able to run these machine learning algorithms, we're going to need to load them up. So I think I got to do install.packages xgboost. So we've heard some pretty crazy statistics, something like over half of all machine learning competition wins, particularly on the website Kaggle, use XGBoost as part of their solution. So this is a tree-based machine learning algorithm, and we've talked about it in previous videos, so you can go back and look at those. But it's a really great place to start, and for a lot of data science problems. And so we'll go ahead and install this. If this takes too long, we'll just kind of talk through what we would have to do. But basically, since we copied the iris data set into my.dataframe, if y'all do the same thing after you have loaded in that data frame, you should be able to just copy and paste this in, and it should run after you've installed XGBoost, and then you do that library parentheses XGBoost, and then it should let you run this this command or this set of commands. So
we
this
need to change that label though.
oh yeah, you're right, because in my data frame, yeah, we have species, so we would have to copy. Oh, all right, let's see, did it fail?
It installed.
It installed. Okay, perfect. All right, so we can do that. So we go my dot data frame dollar label. Okay. And then we're going to put inside of that, we're going to put my dot data frame dollar species. Okay.
Now we should be able to copy.
Yeah, and so then now I think I gotta load the library first. So library
Yeah,
XGBoost.
we might have to drop species as well.
Oh yeah. Let's see. So how do I do that? So my dot data frame. Oh, I remember. We just looked at that.
Yeah, dollar species.
Dollar species.
And
then we're gonna put null in there, right? Is that what you were thinking?
yeah.
Okay. Okay, so perfect. That's gone.
Yeah, so the reason we had to do this was because otherwise label would have one-on-one species would
Correspondence,
be
yeah.
with so we needed to remove that so that it's not testing out in that.
Where does create data partition come from?
Maybe caret.
Let's create data partition R. Yeah, it's in caret. Okay, so we've got to install caret. All right, so we'll see how long that's going. All right, so basically what this is doing, and if this finishes before we finish talking, we'll go ahead and do it. So first, we're going to set a seed for our random number generator to make sure that any result that we get is going to be the same every time. This isn't necessary when you're finalizing a project, but probably when you're in the process of doing a project, it's good for just being able to reproduce your results and making sure that you're not going crazy. And then we're going to do a couple of things here. So this create data partition is like the scikit-learn function split or train test split. And so here we're saying that 85% of the data we want to go into the training data set, and the rest we want to go to the testing. And so basically then here we can say, okay, inside of my XTrain data set, make an XGBoost matrix, okay, that is comprised of my data frame that is only inside of the training data set.
Minus
select out, because we're using minus label, so select out the label column. And then in for Y-train, we just want the label column.
Yeah, so that's basically, so we have 5 columns in our my dot data frame data set. So we have sepal.length, sepal.width, petal.length, and petal.width, and label. So we want the first 4 columns, the sepal and petal ones, to be in XTrain and label to be in YTrain. And so it's the same case in the testing data set as well. In testing as well, we want the first 4 to be in the test and the last one to be in Y test.
Yeah. And so we do the same thing for our X test and Y test, but basically we just put a negative sign in front of entrain, and then that says we're going to use the other half of or the other portion of the data set, 15%, I guess. All right, so now library or caret's installed, so we can do library caret. Okay. Perfect. All right, so now let's try to create our training data set. Okay, So we've got in train, and let's see if it'll let us create our testing and training data sets. Okay, cool. All right, so now, oh, sweet, we're doing cross-validation here. All right, so we've done testing and training split, but to get a nice, robust validation accuracy, we're going to also do cross-validation. It looks like we're doing 5 different folds. So that's basically like saying, okay, you have a testing and training set. Now let's just put aside the testing set for right now, and let's just look at the training set, and let us again split our training set into 5 different training and testing data sets that are different pieces of the data set. And then we're going to train and then evaluate on each different version of those 5. And then that'll give us kind of a more robust look at how generalizable our algorithm is. So if you have a good chunk of data, it's nice to be able to split into testing, training, and validation. And that's kind of what's going on here. All right, so this is a whole function that we're creating. So let's copy this over and make sure we don't get any errors. And we do. So let's see what's going on here. Oh, it's because it's it's doing word wrap.
Oh.
I think. Yeah. All right, so print paste. All right, so let's just look at what else. Yeah, because it's saying that it doesn't know what's going on here. Are we supposed to do? Well, interesting. I don't know why it's commenting out these things. Oh, okay. It looks like these are just different options for the XGBoost. Right. And so we're doing a parameter search here. Oh, okay. So that's part of why they're commenting out things, is because I gotcha. Let's do this inside of an actual script, like script file, instead of in here, because I have a feeling it's going to work better that way. All right, so I'm coming up here. I'm going to click on R script. I'm going to type it in here. And you see it's code highlighted. So this is great because this will probably work. All right, so if I save this, say I think UTF is fine. All right, so we'll just say, we'll just call it the same thing that it is. So param search. All right, so if I run that, okay, it still finds a bunch of errors, but now we can start to take a look at them. Let's see. All right, let's go up to the first one. All right, so what's the error here? Unexpected token. So this must be a Windows quote.
Yeah.
Versus Linuxy quote. Okay. So we're going to go ahead and replace all of these with appropriate single quotes. Or maybe it's something that Medium converted the
Yeah,
quote
I've
symbol.
been seeing this issue lately as well, or at least one other time.
That makes more sense why it was throwing the errors everywhere. All right, so now if we run that,
Another just result.
object results not found.
We do have result. Maybe into.
Let's try copying and pasting this because it might. Not sure why it's not just creating me a function. Yeah, there we go.
Yeah.
I think you've got to save it as something else here if you want a function, like it to actually save as a function, but I'm not sure what that is. So we'll have to figure that out. All right, so now we have a function called parameter search, and we've got to put our data in there. So we'll do parameter search, and then in here we're going to put x train y train, and then, all right, let's see, yeah, x train, y train, x test, y test, okay. X test, and then y test. Oh. Okay. Package E1071 is required, okay. Let's see if I already have it.
It's a very weird name.
It is a weird one. All right, install.packages E1071. Oh, I gotta put quotes around it. Oh, it's interesting. In the editor up there, it does the like automatic quote around things if you do the single quote on a highlighted thing, but in the console it doesn't.
Yeah. Console. That's the word that I was looking for.
Yeah. Okay. So then library E1071. All right. Okay. So now we've got that. And now let's try our parameter search again. Hey, it did something.
So accuracy was 94.5. What is kappa?
Nice. I don't know what kappa is. But did it spit out anything here? So XGBoost grid. It didn't actually give us our, oh, because I didn't put that into anything. So XGB. Let's see. So what is it doing here? We can use it to directly define our working model. Oh, okay. All right. So we put that in XGB underscore model. Okay. All right. So this function does a parameter search. Here it actually looks like we've commented out the parameter search part. Because we're just doing round 60, depth at 20. So we could go back in and uncomment those things and rerun, and it would take a lot longer to run, but it would actually do this parameter search to find what the appropriate values are. So my guess is these are the values that they found to be the best. So we'll just leave it right there for now.
Yeah.
And then we're going to create another thing called best.model. All right, so let's see if this will actually work. Oh, objective.
Again,
Oh,
those quotes, I believe.
yeah. All right, hang on. So single quotes. Okay, let's try that. Object importance not found. No, that's interesting.
Oh, you don't have any importance.
Yeah, where did his importance come from?
I think it is the data set that they are working on.
Yeah, it's just interesting because I don't. My data frame importance. Interesting. It looks like that's some data that they've created.
Yeah, I think it is their data set that has the word importance.
All right.
Oh.
So what we'll do is we'll just see if we can do this plot. But what we're going to do is specify for the model, we'll just go ahead and specify our XGB model and see if that works. I don't know if this is going to work.
It didn't find XGB feature important. Can you try to copy paste that again? And oh, sorry, I can see it now. Error in
So
XGB model must be an object of class XGB.booster.
interesting. All right. Well, we're going to have to do a little bit more. What we'll do is we'll see if we can find an XGBoost documentation example in R so that we can just do an XGBoost example. I was hoping that this one would just work. So, I mean, this is a nice, I've enjoyed this article, but it looks like they weren't super rigorous about making sure that their examples would work for somebody else.
Yeah, I
I
think they
wonder
had a
if they
data
ran,
set.
yeah, I wonder if they ran these things. I mean, they clearly had their own data set, and then I wonder if they also just ran them in not a super clean workspace. Because yeah, it's not super clear. That's a little frustrating, but we'll see if we can find an XGBoost example to do in R. Because as you can see, 95% accuracy is pretty good for this data set. And so we'll have to play around with that. But yeah,
And that's without working through a lot of parameters or anything. If you play around with parameters, you might be able to just get better accuracy with XGBoost as well.
yes, yeah. I think that's accurate. If we actually did the parameter search, I think we would get better. And then also, yeah, just having some real data. I would love to see that feature importance graph.
Yeah.
As part
I
of
mean, generally, if you have tabular data, I would suggest just throwing it in an XGBoost model and just seeing what result you're getting, and you can go from there. That if you need a specific model or something, XGBoost is always a good first try.
Yeah, exactly. All right, well, cool. Well, thanks, Ravi. And we'll just pick out something different. I don't know. I think our data science interns had asked that we do something on clustering, so we might have to do that next week. But we'll try to find another XGBoost example in either R or Python or R or MATLAB to do sometime soon. Probably R, since we weren't able to get this one to finish out working. So
Yeah.
Sounds good. Well, stay safe, everyone, and we'll talk to you later.
Yeah, talk to you next week.